Welcome back. This is Properties of Water and Salinity screencast by Miss Barla, Part 2. So you should have already listened to Part 1. If you haven't done that already, you need to go back and find that link. All right, so where we left off, we had just talked about water's high specific heat capacity and high heat of vaporization, which basically just means it's really hard to change the temperature of water. It requires a lot of energy. Now we're going to be talking about cohesion, all right? Cohesion. If you've ever seen co, the prefix, that means like cooperative, together, or corporation, something like that. Basically, in cohesion, water is attracted to itself, all right? Water is sticky to itself. Water is a polar molecule, and so it's able to bond together. This causes something called surface tension, which you've probably seen before. If you've ever seen a water glass fill up to the very top and it still keeps going, it forms that little bubble on the top, that's surface tension. It's when a liquid resists breaking under stress, and that stress would be a lack of a container. Before I give you guys the why do we care, we're going to talk about the fifth property, which is adhesion. All right, to adhere. So like adhesive tape or an adhesive Band-Aid, right? That means it sticks to stuff. This means that water sticks to stuff. It can stick to other things. Please note that this is a typo. This is bad, wrong. Please make sure that you guys recognize that this is wrong. That should be other things, all right? So use the picture. Picture's best, okay? But adhesive means that it is sticks to other things, all right? Now, why do we care? This allows for certain species of aquatic insects to be able to walk on the surface of water. And I believe I have a picture for that coming up next, all right? Next, if you'll look, plants on the right here, okay? This allows for water to travel up a plant. So if you've ever wondered, how's the water getting up to the top of a really tall tree? Well, that's because water is able to stick to the sides of these things called xylem, and that's kind of like the veins in the blood vessels of a plant. It's also able to stick to itself, so it kind of plays follow the leader all the way up the tree. All right? Next, this also explains dew. So if you've ever been out on the grass in the morning or seen bits of water on it, that's because of cohesion and adhesion, right? We also see again how water can move within plants through the xylem, and that's this picture right here. So those are the 5 properties of water. I do have a summary video here for you.
So we have a riddle for you. Okay, not really a riddle. We're bad at riddles, but more like clues about our favorite molecule. It's polar, it's shaped like an outstretched V, its properties are awesome, and it makes up 3/4 of the surface of the Earth. That one always gives it away. Our favorite molecule is water, and we're not going to lecture you about how important water is and the fact that all life as we know it could not survive without it, because, yeah, that's true. But we really want to talk about what makes water so unique for biology itself. What are some awesome properties of water? Now, we mentioned the shape of water and the fact that water is polar. It has one very electronegative oxygen that is always trying to keep the electrons closer to it than to the hydrogens it's bonded to. And this actually gives oxygen a slightly negative charge because of the electrons that are spending more time next to it, and it gives the hydrogens a slightly positive charge. Well, that means that other water molecules have an easy time bonding together. Why? Well, because the hydrogen of one water molecule with its slightly positive charge can bond to another water molecule's oxygen with that slightly negative charge. These bonds among the water molecules are hydrogen bonds, and these are the very bonds that allow water to have many of the properties that we're about to talk about. Have you ever looked at a really tall tree and wondered, how does the water get all the way up there? I mean, it's got to go against gravity. Gravity? Well, in our plant video, we talk about the xylem, It's vessels within certain types of plants, like trees, and these vessels transport water. But what's really neat about water is that it sticks to the xylem walls in what is known as adhesion, and this helps fight gravity. But water molecules, with their hydrogen bonding, they also bond to each other in something called cohesion. It's almost a beads on a string kind of fashion. Water molecules evaporate from a leaf, and then the next water molecule in line is pulled upwards, and so on. This cohesion is really a big deal. Cohesion is also a reason that water striders, one of our favorite insect types, can skate on water.
These were the insects I was referring
contributes
to.
to the surface tension of water. Water actually has quite a bit of surface tension compared to many other liquids. And it's not just water striders that can walk on water. There are a lot of insects, spiders, and even larger animals like reptiles and some birds that have the ability to walk on water. So, to the Google for that. Now, with water being polar, it's also a very powerful solvent for other molecules. And that means that water can dissolve many other molecules, especially polar molecules and ionic compounds. Now, why does that matter? Well, this is really important because many of the processes that occur in organisms use water as a solvent. In our body system video, we talk about the function of kidneys, and you definitely couldn't have kidneys doing their function without water. Also, a main component for body fluids is water. I'll never forget when I was little, my father built us a pond. We had some goldfish in there, and I loved this pond. Well, in West Texas, where we're from, it can freeze in the winter. And one morning, I went outside, terrified to find that the top of the pond had frozen. And I thought our fish were goners. Only to find out that they were swimming and doing their fish activities under the ice layer. It's common for many substances to actually contract when they freeze and to become more dense. But water expands when it freezes and becomes less dense in its frozen state, resulting in floating ice, where it can actually make this insulated surface layer that makes a difference for many organisms underneath. And this is due to the hydrogen bonds. See, at freezing level, the making and breaking of hydrogen bonds, which usually happens pretty often, it's not happening very much when frozen. And so the molecules, they're set into this lattice of hydrogen bonded molecules, just far enough apart that it's less dense in ice form than it is in water form. And that's going to be very important for all of that aquatic life. Speaking of temperature, water resists changing its temperature. It has what's called a high specific heat. Specific heat, it's a measurement of heat that's needed to be absorbed or lost for 1 gram of a substance to change its temperature by 1 degree Celsius. And that's why on the first day that school is out in the summer, it may be super hot outside, but the water could still be pretty cool. It's really good that water's like this for life. It's stabilizing for aquatic environment temperatures. And it also means that water can absorb a lot of heat in the summer without reaching as high of a temperature itself, which is useful when winter comes along, because then the water can release heat as it cools in the winter. This also impacts the environment. Now, still on the topic of temperature, consider evaporation. Many animals rely on evaporation to cool them. Think of water molecules. They are moving, but those that have more heat energy, they're moving the fastest. And they're the more likely molecules to make the phase change to gas. And these molecules, as they leave, their energy, their heat, is no longer on your skin. And by the way, all of this is not just animals too. Plants use evaporative cooling to aid them in hot temperatures. Excessive high temperatures could be very dangerous for many different processes in both plants and animals. It can be damaging to the enzymes involved in those processes. So, that evaporative cooling is very important. Well, we went through a lot of features of water. Definitely something to consider next time you encounter it, which, based on how much we depend on water, will likely be soon. Well, that's it for the Amoeba Sisters, and we remind you to stay curious.
All right, so that is the properties of water. We're now going to transition into salinity, all right? And what I'm referring to is salt, or specifically different substances dissolved in water. Note, Salt Bay. So in case you didn't know or haven't been recently, ocean water is not 100% pure water. That's why it tastes so gross sometimes if you drink it on accident. It has dissolved substances in it, which includes salt, but there's a lot of other things to it. So this is what makes seawater a solution. Now, I'm not talking about the solution to your problems. I'm talking a chemistry solution. A solution is a mixture of two or more substances. Usually this means we're going to have one substance dissolved in another. So if you've ever made Kool-Aid, right, you have to have your Kool-Aid powder and your water. You add the amount of Kool-Aid you want and you make Kool-Aid. If you have less Kool-Aid powder and a lot more water, that would mean you have a dilute solution. If you have a lot of Kool-Aid powder and a little less water, you would have a concentrated solution. All right? Now there's three terms we're going to focus on today. First one being solution, which is the mixture. We have a solute, and that's what gets dissolved. All right? So in the example of Kool-Aid, it would be the Kool-Aid powder, what you put in. The solvent does the dissolving. So in this instance, it would be water. I want you to think, what would be the solvent in the ocean? And what would be the solute? Have any guesses? Well, the solution is ocean water in its whole entire thing. Water would be the solvent, and the different salts that are in it would be the solutes. Also, we're going to take a moment to appreciate this great joke. If you didn't laugh, you need to get better science humor. Now, what are these salts? What are these dissolved substances? There are a lot of different parts, but mainly we'll have chloride, sodium, sulfate, magnesium, and calcium. So that's why when people say that the ocean is saltwater, it's because these are all different types of salts by definition. But also when you have sodium and chloride together, you make table salt. Do you think the ocean is equally saline, meaning salty everywhere? Have you ever been to a different ocean besides the ones here in Santa Barbara? Well, for instance, I've been to the Dead Sea. The Dead Sea would be somewhere around here in Israel, where my family's from. And in the Dead Sea, it has the highest salt content of, I think, any other body of water. It's so salty that humans actually can float in it. And now I've been in it, it's actually hard to swim or stand in it. It's that buoyant because there's that much salt. And people use the salt to rub on their skin and use it as like a hydrating serum. All right? Now, if you notice, according to this map, it's measuring salinity and color. So the light blue would be lowest and the red would be highest. So it would make sense why by the Dead Sea, it's super red. By Santa Barbara, it's light blue. So if you think our oceans are salty, you got another thing coming. Because look at all these other regions. Yellow and orange, red in certain spots. All right? Now, what do you think that means for our marine organisms? Do you think organisms from Santa Barbara would survive in the Dead Sea? Do you think any organisms can survive in the Dead Sea? That's something I want you to ponder. What do you think it means for our organisms that the ocean is not equally saline? We're going to come back to that one tomorrow. You've reached the end of our screencast. Your homework for tonight, you're going to finish any of the notes from today or yesterday, so either the chemistry review or the salinity and properties of water screencast. Make sure they are done and thorough. I want to see pictures in this one if you didn't draw any. Okay? You also have to finish the check for understandings or CFUs that are on NEO for both the chemistry review and the properties of water. There's two, but the properties of water one's a lot shorter, so don't worry. Lastly, wear PPE tomorrow. Remember, PPE is personal protective equipment. So pants, hair ties for your hair back, shorter sleeves, stuff like that. We're going to be doing a lab and it's going to be super fun. That's it for today. Thanks.